Okay, hi, grade nines. So we're still on page 327. This is number 15, and of course, my question makes it fake number 15. Let's get into it. The same instructions. I didn't bother retyping the instructions because I'm going to do virtually the identical question. Okay. So it says the two rectangles have equal perimeters. Okay. Now remember in grade 9, they automatically assume you know the difference between a perimeter and an area, and they know that they assume you know what a perimeter is, and they assume you know what an area is. Next question deals with area. This one deals with perimeter. The two rectangles have equal perimeters. What are the dimensions of each rectangle? Okay, well, again, some of these more complex problems, I'm really a fan of organizing things and sorting the information, okay? So, again, it might be helpful to draw a T-chart, okay? In the end, you have to. You don't have to. I see you guys' notebooks. I just like to be super organized as much as possible because I do think it makes it easier for you to understand. Okay, so let's talk about. Sorry, we got to get this to a pen. Let's talk about. Now we're doing my question, okay? So we're talking about A here. Okay, and then over here, obviously, we're going to talk about B. Okay? B. All right. So what is a perimeter, right? It's all sides. Now, there's a shortcut here that you can use the distributive property to help you out do stuff a little bit quicker. But I'm going to skip it, and I'm only going to skip it because I actually want you to see how everything adds up. So you have to remember that if a perimeter is the distance around, you need to know all sides. And we're not obligated after a certain amount of time. We don't have to give these little tick marks. You can make that assumption. But basically for rectangle A, okay, so what's a perimeter? Well, the top side is the same as the bottom side, okay? And so why don't we just stack these up with like terms? Yes, a little polynomial is there for you. And let's add up all the sides, right? So we've got top, we've got bottom, right? Let's add the right side since that's given to us, 3.5d plus 0.75. So that was the right side. And we're going to add 3.5d again because it's the same over here. This is the same as this, and this is the same as this. So there's four sides is what I'm trying to remind you of. Hopefully you remember that. Okay, so 0.75, and that's the left side, okay? All right, so let's stack and add because we can have one ginormous, simplified, gather the like terms expression for the entire perimeter of rectangle A, okay? All right, it's going to be easier to do mental math. 6.5 plus 6.5 is 13, and 3.5 and 3.5 is 7, and 13 and 7 is 20d. Please remember from polynomials it's 20d. Don't be tempted to write d to the 4. That will make me cry. It's just 20d. Adding to what? Well, $3.50, that's 7 and 75 cents times $1.50. So this is $8.50. You guys can check my math. Hopefully I get it right. By the way, if you guys think I made a mistake, please comment in the comment box, right? Don't think me as infallible or the math god because it's just not true. Over here for question B, for rectangle B, this time I will use the distributive property because look how repetitive this gets. So let me show you what I mean. So let's talk about top and bottom here at the same time for question B. Actually, I'm really glad I thought of this on the fly because you can see both. Okay, I have two identical sides, grade 9s. That is defined by 7d right here. 7d plus, whoops, not plus, Mr. Smith, minus 0.75, okay? So then if I distribute, right, I have top and bottom, I essentially have 14d minus the double of 75 cents is $1.50. Do you notice how I talk in money still when I get to decimals? I find it easy. Now, as far as the right and the left go, Okay. They are two sides, right? I have this one and I have this one. And no, I don't need to label it, but it's assumed that it's a rectangle, for crying out loud, right? It's a rectangle. Of course they're equal. I have two sides of 5D plus 1. 5D, that's supposed to be a curved bracket. 5D plus 1. Distribute that. Okay? 10D plus 2. 10D plus 2. So in the end then, I'm just going to switch colors here just for a sec. So in the end, I have 14D minus $1.50 minus 1.5. At this point, I don't need to talk about money anymore. Plus 2. So what's the result of this? 24D. Now, 2 minus $1.50. I will still talk about money. What are we left with here? 0.5, right? Remember, this is the same as 2.00. So I'm left with the positives win this fight by 50 cents. Okay? So, and these two perimeters are supposed to be equal. So they're supposed to be equal. They're supposed to be equal. This is supposed to equal this. Okay? Now, you can see I'm out of room, so I'm going to pause, and I shall return with an expression all glued together. Okay? Give me just a sec here. Okay, I'm back. So what we're saying is the perimeter of A, right, is supposed to equal the perimeter of B. So if that's true, right, if the perimeter of A is 68 centimeters, the perimeter of B must be 68 centimeters. All we've done differently is, of course, we've complicated your life on purpose because we just love doing that. We've given you the perimeter in terms of an expression. We have the expression for the perimeter of A, which was 20D plus 8.5. That's what happened when we added this to this one. So this expression twice, added all together, 20D plus 8.5. Over here in rectangle B, we added 5D plus 1 plus 5D plus 1, 7D minus 0.75. Same thing here, except I use the distributive property. And by the way, it's up to you to think if you just want to add all the sides up and stack them up like we did in the polynomials unit, that's fine. If you want to use the distributive property because you think that's easier, that's fine. Doesn't matter to me. But basically, you better, at some point, grade 9s, you better end up with this equation. This is the secret sauce. This is the magic cookie dough recipe. Okay? So, I'll just start to show how important this step is. All right. In other words, you should have, at some point, this is the middle of your problem. Okay. I'm going to do what? I'm going to subtract 20D from both sides. This is where my experience of doing 70 billion questions comes in handy. And the reason is this. I know that 20 is a positive number. I know that 24 is a positive number. 20 is less than 24. So when I take 20 away from both sides, I end up with an already positive 4D. Little hint there, little advanced sort of hack, inside trick. How do I decide what side the variable should go? I usually try to guess in advance, and I'm pretty good at it now, of where am I going to end up with a positive coefficient? I just like it that way. You don't have to do it that way. The point is you have to get to the variables on one side. Oh, so I didn't do this very satisfying thing. That's a big ginormous 0. Whatever you do to one side, you do to the other. And now I'm going to subtract 0.5 from here. If you want to throw in your invisible zeros because it makes you feel better, go ahead. And the very satisfying 0 out there. Nice little 0 pair. 850 minus 50. $8.50 minus 50 cents is 8. Oh, golly, I like this. Look how nice and whole numbers these are. 8 is equal to 4D. Let's divide both sides by 4. You know, I made these problems up on the spot. I'm doing pretty good here in terms of making the numbers work. I have to say I'm doing pretty good. Okay? I have to change all these numbers. 2 is equal to D. So that does mean, literally, if I were to put in a 2 here, and if I were to put in a 2 here, and if I were to put in a 2 here, And if I were to put a 2 here, oh, it's my face is in the way. Face is in the way. If I were to put a 2 there, right, you'd have the same answer. So in fact, let's actually go back to the original equation and check this answer. All right. So perimeter A is supposed to equal perimeter B. So this was what, 20? And now we're saying D is equal to 2. So 20D, in other words, 20 times 2 plus 8.5. Hopefully, cross your fingers, that's the same answer as if it were 24D, except I'm replacing the D with a 2 now. That's the whole point of solving, folks. It's so that you can swap in the number. You can use your solution. And this was supposed to equal the constant here was 50 cents? Yeah, it was. All right. 20 times 2, 40. Plus 8.5. Boy, my bit paper is getting laggy, and it's like at night. And this is 2 times 40, 2 times 24 is equal to 48 plus 50. Holy mackerel, I think I'm about to be very happy. 48.5 is equal to 48.5. And yes, ladies and gentlemen, I am very happy. This is a yay. All right. Hopefully that helped you. All right. See you on the next question, grade 9s. Cheers.